All right, we are starting a brand new topic. I hope you like the brand new opener that I put there. Figured I'd send out some good vibes. We're starting on topic 3, and topic 3 involves numeric and algebraic expressions. Well, expressions, you know, of course, those are things like 3 plus 1 or whatever. That would be numeric because it has numbers. And algebraic, well, we're going to learn about those, but those have variables like letters like x and y and a and n to represent unknown quantities. We'll get into that later. Today, we're looking at exponents and exponential notation and what that's all about. So this is an example of exponential form. It's just a way to write a number differently. So this is 2 to the third power. And the way I would change that to standard form is the base, which is this bottom number, is the factor. And the exponent, which is this little number up here, tells you how many times you are multiplying them together. And so 2 times 2 is 4, times 2 is 8. All right, thing to look out for. It's very common for students to want to say this is equal to 6. They just want to multiply the exponent times the base. That is not correct. You need to multiply the base by itself the number of times the exponent tells you. So one more here. I have 3 to the third power. Again, that's 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Okay, so that's exponential form, and we're going to be working with that a lot today. Some quick vocabulary to go over. The base, we talked about that. That's the bottom number. That's the factor, the repeated factor. Evaluate's just a fancy way of saying get the answer. Exponent, that's that little number on top of the base that tells you, or to the side and up, that tells you how many times the base is being multiplied by itself. And a power is just sort of, it's the exponent to the power of what? To the power of 2, to the power of 3. It's whatever the exponent tells you. All right, so here's a practical application of exponents. We have bacteria cells, and they often reproduce by just dividing. So you have one little bacteria here, and it splits in half, and you end up with 2 bacteria. And then they split in half, and you end up with 4 bacteria, and so on and so forth. So if we have a bacteria cell that divides every 20 minutes to make 2 new cells, we want to know what we end up with after an hour. We're starting with 1 cell. So let's make a table to track our information. Okay, so for the time, we start with time 0. And at 0, we're going to have 1 cell. I'll come back to the exponential form of that later. And then 20 minutes later, I'm going to have, it's going to double. So I'm going to take my original cell, and I'm going to double it for a total of 2 cells. Then at 40 minutes, 20 minutes later, I'm going to take my original answer from before, and I'm going to double that, which gives me a total of 4. And after 60 minutes, I'm going to take what is above it, and I'm going to double it, and I get 8 cells. So there's 8 cells after an hour. And the reason I wrote it out like that is because if you look, at 60 minutes, I have 2 to the 1, 2, 3. There's 3 of them, 2 to the third power. And for the one above it, that's 2 to the second power. And then this one, there's only 1 of them, 2 to the first power. And here, there's none at all. We call that 2 to the 0 power. And we're going to talk about that a little bit more later on, but trust me on that. And just to reiterate, the answer is 8 cells. All right, this is something for you to try. It says there are 2 times 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 2 bacteria cells after 3 hours. We want to write this repeated multiplication as a power, okay, in exponential form, and then evaluate it, which means give the answer. So we're going to rewrite this using an exponent, and then we're going to solve it. We're going to get the answer. What is it equal to? Go ahead and give it a try. We'll talk about it in class. Okay, here's a table for 2 to different powers, and we want to find out what is the value of 2 to the 0 power. This is what we were talking about earlier. So if I have 2 to the 4th power, that's 16. 2 to the 3rd power is 18. 2 to the 2nd power is 4. 2 to the first is 2. And so what is 2 to the 0? Well, notice every time I go this direction, it's times 2. Times 2. Because I'm multiplying by one more 2. So what times 2 is 2? Well, that's just 1. So there's showing you what the answer, how that works out. All right, here we go. We have 1 and 2/10 to the 4th power. So this is 1 and 2/10 times 1 and 2/10 times 1 and 2/10 times 1 and 2/10. And I'm going to multiply these 2 at a time. That's going to make things a little easier. And 1 and 2/10 times 1 and 2/10. Well, I know that 12 times 12 is 144. And then I got to move my decimal over 2 places. And I get 1 and 44 hundredths. And if I do the same over here, I'm going to have another 1 and 44 hundredths. If I multiply those together, that's triple tremble, I end up with 2 and 736 10,000ths. And that's how that's done. Here's one for you to try. You know what exponents mean now, so you can expand that out, and you know how to multiply fractions. So go ahead and find a solution. Evaluate 1/3 to the 3rd power. Okay, we're going to use exponents to introduce you to something called scientific notation. It's used in science all the time, and it's a nice way to represent either really huge numbers, like distances between planets, things like that, or really tiny small numbers, like maybe the size of atoms. We won't get into the really small part now. We're going to get into the really big part. But for instance, you could write 250,000 as 2.5 times 10 to the 5th power, which maybe doesn't seem like it's a lot easier to write. But what if we had, like, say, 3 times 10 to the 12th power? Well, that's 1, 2. That's that number. Who wants to write that? I mean, you fill up your whole page with whatever that is. And so it's a matter of convenience. So let's look at this. First, we want to look at some patterns, okay? And this is going to help us out seeing how we can do a lot of this work mentally. So 10 to the 0 power, anything to the 0 power we learned is 1, and a 1 is just a 1. 10 to the 1st power is just 10, because I only have 1 10, which is written as 10. Now, hopefully, we remembered that this is 10 to the 2nd power, and you know how to do 10 times 10. That's 100. 10 to the 3rd power is just going to be 10 times 10 times 10. Well, 100, well, we know how to do some mental math there. 1 times 1 times 1 is 1 with 3 zeros. So that's 1,000. 10,000, that has 4 zeros. So I must have had 4 tens, which would be 10 to the 4th power. Now I have, here I have 1, 2, 3, 4, 5 tens, 10 to the 5th power, and I know that's just 1 with 5 zeros. And finally 10 to the 6th power would just be 10 multiplied by itself 6 times, which is a 1 with 6 zeros, or 1 million. Well, I want you to notice is the exponent tells you how many zeros you're adding to a 1. So this exponent of 0 tells you there's no zeros. And look, I have 1 with no zeros. The 1, I have 1 0. The 2, I have 2 zeros. The 3, exponent of 3, I get 3 zeros, and so on and so forth. So if I had, for instance, 10 to the 9th power, I don't even have to think about it. It's a 1 with 9 zeros, or 1 billion. So that's the pattern we're looking for there. So powers of 10 are pretty easy to work with. And looking at some more patterns, I know if I can multiply these out, 5 times 100 is 500. I do 5 times 1, the non-zero numbers, and I tack on the 2 zeros. So this one here is going to be, ooh, what is that going to be? Well, let's see. I'm going to get out my calculator, and I got an answer of 50. And then I have another calculator. I'm going to pull that out, and I'm going to get 500. And then we have this. We're going to do 2 2,500. And then we have 60,300. Okay, so let's look at this on our place value chart, because I know you guys did a lot of this in elementary school. I'm starting with my first problem, 5. And I want to multiply it by 100. That means I'm making it 100 times bigger. So it's going to go 10, 100 times bigger. It's going to end up right here with 2 zeros. Every time I multiply by 10, my number moves to the left 1 place. So with 5/10, I'm making that 100 times bigger, according to the second expression. So I'm going to make it 10, 100 times bigger. It moves to there. And I end up with my 50. So basically, every time I multiply by 10, I move the digit to the left, which means the decimal point kind of moves to the right. So if I look at this pattern, my decimal point starts right here, and it moves over. I have 2 zeros, or an exponent of 2, when moved to the right 2 places. Right here, I have 2 zeros, or it's 10 to the second power, and move that over twice. 1, 2 ends up right there. The next one, my decimal point started here. 1, 2, 3. Started here. 1, 2, 3. Started here. 1, 2, 3, 4, because I have 4 zeros. So if I had, for instance, 6.2 times 10 to the third power, I have my 6 and my 2. My decimal starts here. 1, 2, 3. Fill in your zeros. It's that easy. So let's put this all together. I have 6 times 10 to the second power. That's basically 6 times 10 times 10. I know I have to move my 6 2 places to the left in the place value chart, or the decimal point 2 places to the right. I'm making it bigger. So here's 6. I can make it bigger by going this way, 1 place, 2 places, decimals there. Fill in your zeros. 6 and 3/10 times 10 to the second power. My decimal point started here. 1 10, 2 10s. Ends up right there. 6.03 times 10 to the fourth. Decimal point starts here. 10, 1 10, 2 10s, 3, 4. Ends up right there. I get 60,300. I'm going to ask you to go ahead and work on that last one by yourself. All right, let's put this all to use in the real world. So Julia calculated the foil as having 1 9/10 times 10 to the 5th units in thickness. Must be a super small unit if it's that much thickness to it. Thom calculated the foil as 183,000 units thick. Which calculation represents the greater thickness of the foil? So we're comparing 183,000, we know what that is, to 1 9/10 times 10 to the 5th. Well, we just learned that that exponent tells me how many places to move my decimal. So I have my 1 and my 9, and my exponent is a 5, so it's going to go over 1, 2, 3, 4, 5, fill in with zeros, 1, 2, 3 there. So it looks like the greater thickness is what Julia calculated. All right, and the next problem, Raphael calculated the foil as having a thickness of 1 8/10 times 10 to the 4th units thick. We want to know what his expression is in standard form. In other words, just as a number. So figure that out, and we'll talk about it in class. All right, well, here's some straight up practice. Go ahead and solve these. We have 1/6 to the second power, which is also read, sometimes the second power is read as squared. So that's 1/6 squared. We have 7 squared, or 7 to the second power. And we have 4 5/10 times 10 to the 4th power. Go ahead and evaluate those. We'll go over them in class, and have yourself a great day.